What's up, guys? We are back with day 2 of Advent of Code 2023. Today, the challenge I thought was looking pretty scary when I first read it, and then as I continued reading it and saw what they wanted us to do, it became not as scary. So, if you haven't seen it already, we get input files that look kind of like what I have here, or exactly like what I have here. The first part gives us a game with some ID number, and then it gives us the balls that an elf extracts from a bag. And separated by semicolons are different rounds of this game. So in the first round here, you can see that the elf pulled out 3 blue, 4 red balls. The second round, we got 1 red, 2 green, and 6 blue. And finally, 2 green balls. And these are with resampling, which is one of the things that was starting to scare me about reading the problem. But at the end of the day, part 1 is just giving us these numbers. So these are the constraints of the problem, basically. We have a maximum of 12 red balls, 13 green balls, and 14 blue balls. And it wants us to go through each of the games and find the valid games. So some of the games have rounds where, for example, 18 green balls are pulled out. So we know immediately that that round is actually invalid for these constraints. So to do that with awk, it's a little simpler even than yesterday, I would say. We're not messing with any of the special field separator variables or anything like that. We just jump straight in and extract the game number. You'll see we've got some more descriptive comments today. And I also left in some print statements that'll help us get a feel for what the code actually does. So as I say here, the first thing I do is extract the game number and remove this game prefix. So each of the lines is prefixed with game and then a number. And we don't really care about the game part, we just need to know the number, because the way we get our final score is by adding up the game numbers of the valid rounds. So we get the game number, put it in the variable named game. Then I just extract I locate the colon in the line because I want to strip off the whole front part of the line. I thought I was going to say I wanted to strip it off of the game number, but what I actually do, we take care of that right here. So we take the length of the game number and subtract 1. So I think when you see these purple things, those are built-in functions. So awk has a bunch of string handling functions, substring, length, index, and some others we'll look at later, split and match. So okay, once we've stripped off this game 1 part, we're left with just the actual rounds themselves. And that's what I'm printing right here. So you'll see that I'm printing the game number and then what's left of the line, the rounds. Now, as I mentioned, awk has a split function, so we could just split each of the rounds apart using the semicolon separator. And then one of the weird things about some of these awk functions is that they often take an array and they store the results in the array instead of returning them back to you. So what you can see here is that I pass in the name of the array I want the results in, and then I can use this for loop to loop over the indices, something that trips me up sometimes when using this kind of for loop. This loops over the indices in rounds. And I guess I'm printing that as well. You can see it's indented with a tab, which apparently is quite wide in my setup. And you have to do rounds of round. This, I can't emphasize this enough. It didn't trip me up today. I'm used to it by now. But I used to run into lots of trouble with awk. Because this iterates for round in rounds. Round is the index into rounds. So you have to do this to get the actual element. I think in Python, if you said for round in rounds, you would get the round. So make sure you keep that straight if you're new to awk. And then always say, if the round is not valid, again, rounds of round is the round. So it looks like this. If it's not valid, then we call next, which moves on to the next line of the file and does not evaluate sum plus equals game. So in the case that it is valid, we will hit this line, and that's how we add up the game numbers for the valid games. And again, at the end, we print the final sum. So most of the work, of course, is being done in this is valid section, or in this is valid function. And this actually has another kind of cute thing. Cute or unfortunate, depending on how you look at it. But awk doesn't have a concept of local variables for function definitions. So a trick to get around that is to include them as arguments to your function. And what I mean by this, if that's not clear, is that any variables that you use inside of a function automatically become global variables. So if you don't use this trick and pass them as dummy parameters, often separated from the real parameters by spaces like this, then any assignment I make to red, green, blue, or buff inside of the function actually affects the global variable. This isn't such a big deal for a small script like this, but if you're writing a large awk script, which some people, including the authors, might say you shouldn't do, then you can get into some real trouble where you think you're using a local variable, but it's not so local. So there's a trick / idiom / tragic design flaw of awk for you to remember. So the first thing I do is just set all of these to 0, and then we use this match function, which takes our first argument, which if you'll remember up here is our round. So it tries to match in the round for some number of digits in a capture group, followed by red, and it puts the results into buff. And to extract the first capture group, you can just do buff of 1. So if we find some numbers followed by red, we read the first capture group. Same thing for green and blue. So that turns a line like this into red equals 7, green equals 2, and blue equals 6. And then we just return whether any of those or all of those are possible given our constraints at the top. So if we run that, we get my correct answer, 2076. Okay, moving on to part 2. So you may notice possibly a jarring change in the code. I actually had to check out the old version of the code for part 1 because today's part 2 was fairly substantially different from part 1. Now you'll see that the beginning part is still the same, where we're extracting the game, trimming it off the front of the line, still printing the line. We still do the split on this, but this time the challenge is to check for they call it the power of the round, or of the game, I think, which is the product of the minimum number of red, green, and blue balls required for the rounds to occur. So in this case, we initialize the max values to 0, and then for each round we go through, we update the max values. It's a little bit weird because the question is always talking about what's the minimum number of balls that could lead to these games. But when you're actually writing the code, you're not looking at minima, you're looking at maxima, because you need the maximum number that actually occur are the minimum number that would be needed. So small terminological, basically, hurdle. So we initialize them to 0. Again, we loop over the rounds. As I'm writing here, we are reusing most of the logic in our isValid method, or function. But note that we removed red, green, and blue as these dummy parameters. So now, every time I do these sets inside of the function, I'm setting them globally, which allows me to use them out here. So I just use the same kind of function, basically. We're also ignoring the return value. And then I wrote this small max function that's not built in. We may not have seen it already, but awk does have this ternary operator. So this just says, if n is greater than m, return n, else return m. So each round, I just set each of the maxima to the max of the old value and the new value. And then, as I was mentioning before, the power is just the product of those maxes, and then we add it to the final sum, and we print it out. I think I'm actually printing something slightly different here, which is why it looks different. But you can see there's my correct answer, 70,950. So I hope you guys enjoyed that, and I'll be back tomorrow, hopefully, with our next day of Advent of Code 2023.